Welcome to the Systems Integrator's Playbook for Autonomous Infrastructure, focusing on deploying the Hermes Agent. This is designed for a private, stateful, self-improving AI. The Hermes Agent is part of the coding agent ecosystem, alongside tools like Claude Code and OpenClaw. It emphasizes a highlight on data and modernized data in the background. We are shifting the paradigm from reactive, stateless chat to a proactive, stateful approach. Stateless large language models suffer from the memento problem, where context dies when the window closes. Stateful agents use persistent context files, executing tasks via Crons, and saving learnings to a database. The architecture of Hermes is built on 5 pillars centered around the Hermes Runtime: memory, skills, soul, Crons, and self-improvement. These elements work together to provide a robust, autonomous system. The system solves the stateless wake-up problem by loading user, memory, and soul files at session start to form the active agent context. Remember a critical warning: do not store secrets, API keys, or temporary task status in durable memory files. Procedural memory addresses the context bloat problem using progressive skill disclosure. Skills are divided into a YAML front matter, or the menu for general conversation, and a markdown body, or the recipe, which is only unlocked when the agent needs to invoke the specific skill. Autonomous scheduling utilizes natural language Crons. This involves 4 steps: from scheduling resources to unique systems, to improving content in the index, scheduling data, and finally acclimatization for natural scheduling. A safety nuance is also mentioned. The self-improving flywheel is a recursive process. It starts with executing work, moves to operator correction if mistakes are found, then updates the state by creating or updating skills, and finally, the agent wakes up smarter for the next session. The production infrastructure stack includes the Hermes Runtime and OpenAI Codex inference for the application layer. Isolation is provided by a Docker container via a one-click deploy. The operating system is Ubuntu 24.04 LTS, running on Hostinger VPS hardware for stability. Interface modalities include the CLI cockpit for deep work, offering full access for managing complex projects. The Telegram Remote Control, or On the Go, provides abstracted context management for deploying scheduled Crons and low-risk daily tasks. For security governance, avoid the anti-pattern of pasting tokens into chat, which burns them into conversation history. The production standard uses .env configuration, where credentials are written outside the agent's conversational awareness via the isolated Docker terminal. State management and disaster recovery use a nightly GitHub sync to protect custom skills from VPS corruption. A Docker container is synced to a private GitHub repo via an automated cron trigger, secured by a safe.gitignore shield. For multi-agent architecture, container isolation is key. The mega-agent anti-pattern, cramming everything into one agent, risks context rot and security issues. The least privilege rule dictates that each agent runs in an isolated Docker container with separate memory and billing. When scaling operations, provisioning a new agent is necessary if a workflow requires distinct API keys, separate long-term context, or is an ongoing, repeated background workflow. Otherwise, keep it in the main personal agent. The Operator's Handbook offers continuous maintenance tips. For an agent forgetting instructions, clear outdated lines in memory.md. For repetitive prompts, turn the interaction into a reusable skill. To fix off-tone responses, edit soul.md to constrain response styles. This is a system to continually refine.